All right, welcome back everybody. We are moving into project 11 of our Arduino starter projects, and this one is our crystal ball, or some of you may think of it as the magic 8-ball. Regardless, it's a mechanism where we get our questions randomly answered. In this case, we're going to use a electronic display. Obviously, we're dealing with our Arduino, so we will jump into that, and it's our liquid crystal display. So I guess that's why they're going with crystal ball. So let's go ahead and jump right into the code. Now, when we start with this particular project for this presentation, we're not going to jump into the setup and the loop just yet. We're going to start with something that is going to be a little bit new. And here we're looking at the include of our liquid crystal header. And this pulls in our liquid crystal library overall. And you can see here that we have a variable, we just call it LCD, and then we have these 5 parameters that we're passing into the to the constructor. I'm sorry, 6 parameters that we're passing into the constructor. And what these 6 parameters represent are the numeric values for the pins on our Arduino board, and we're going to take a look at that really quick. So here we have our digital pins 12 and 11. And those, again, they just line up to the digital pins on our Arduino board. And next what we have is our pins for 5, 4, 3, and 2. And just like 11 or 12 and 11, those line up to the digital pins on our Arduino board as well. Only this time they line up to pins 5, 4, 3, and 2. Okay? We'll talk more about where the alignment of these pins kind of go from our board into the display component in a little while. But for now, just realize that this is just the constructor for our LCD variable, which is of type liquid crystal, and it takes 6 pins that we are going to associate from our Arduino board into the LCD device a little bit later. And you'll see more of this when we walk through the board as well. Next, you've seen this before. We're just going to set up a input pin, and this input pin is going to be what we read in from the hardware. In the book, they have the tilt sensor. That tilt sensor that comes with the Arduino board is an enormous pain in the neck. I don't know, I'm just not going to use it. What I've done instead is I put a button. The purpose of this program or this project is to learn how to work with the LCD, not how to figure out what a tilt sensor is. So as opposed to having to pick up the board and twirl it around and shake it, I'm just hitting a pin, right? I'm just going to press a pin and it's going to give us a new message. And so all the code, everything else, exactly the same. I'm just going to use the pin. You'll see it on the board when we walk through it later or in the next video, as opposed to the tilt sensor. That's it. So next what we have is we have 3 variables that we're ultimately going to wind up using that are going to give us the message, a random message, and that's where the reply variable will be used. We'll look at this later on. And then the switch state and the previous switch state. We'll look at this in more detail again, but basically we need to know when they tap the button, when they lift the button, or if they're holding down the button. And we're going to use the switch and previous switch states for that. That's about it. And the reply will be a random number that we generate to give us a random, I guess, look into the future kind of message. Again, we'll look at more of this in the code in a little bit. So that's really all that there is for this project as far as variables are concerned. Really not a lot there. It's just, a lot of detail within the liquid crystal that we're going to look at and a little bit more detail here for the setup. But before that, the very first thing that we need to do is we need to set up our pin mode for pin 6 as input. Again, this is what we're going to read in when the user presses a button. Next, we are going to be looking at actually setting up the LCD itself, right? The piece of hardware. And here you can see that we have the LCD begin and we have the LCD print. And what I want to do is focus initially on the LCD begin. And you'll see these 2 numbers, 16 and 2, in the parameters to that method call. And what that represents is 16 columns and 2 rows. So when we're talking about 16 columns, right, that's going to be the number of columns that we have going across, and 2 being the number of rows that we have going vertically, up and down. So basically what this begin is telling the LCD library is that we are configuring a LCD device that is capable of having 2 rows, and each row has 16 columns. What that's going to look like graphically, just to kind of clear it up a little bit, we're going to kind of have these lines outline which each individual cell, if you will. But you can see here that we have 16 columns and 2 rows. And when we talk about our columns, we start at 0 and we go to 15, right? So 0 through 15 is what gives us our 16 individual or unique column numeric values. Same with our rows, only this time we have 2. So we have row 0 and row 1 to give us our 2 rows. And so that's what this hardware looks like now to the library, now that we passed in the 16 and 2. The next part, the print, where it's ask thee, we'll talk more about that here in just a moment, but the important thing is right now we understand that we have 16 columns and 2 rows. The other thing to keep in mind is the active cell, if you will, when you call begin is 0, 0. Okay, and so we can see in the graphic that the active cell that we have when we call print, the very first character, in this case the A from the ask, will go in that cell 0, 0, which is what we want, right? Ask thee, and then we're going to go to the next line and print out another message, right? And so begin goes to 0, 0. And it does that by default when you call the begin method. Next, we are going to set the cursor, and we're going to set that cursor to 0, 1, and that's where the C for crystal ball will go. And each time that we print out a single character, the cursor will automatically increment to the next column. Now, if you start to get to the end of the columns, it'll start looping around. And so that's why you want to be careful to set the cursor before you do the print. And we'll look at clear here in just a minute, where we clear out all the text that's in there. But for now, we call begin, we automatically go to 0, 0. We're going to print out ask thee, and then we're going to set the cursor back to 0, 1, and then we'll print out crystal ball. And we'll do this here in just a moment, but just understand what the set cursor and the begin kind of do with the positioning here. So let's say we're looking for 5, 0. When we got right now, we have set the cursor at 0, 1, but if we wanted to set it to 5, 0, we would go to column 5, and then we would go to row 0. And that would put the cursor at this location, 5, 0. So if we were going to call print after that, this is where the first character would go. Let's go ahead and take another a look at a different one. We'll move down to the first row. Let's say we'll go to we'll go to 9, 1. And here, same exact thing. We want to go to column 9 and row 1. And so again, if we were going to print out XYZ, the X would go at 9, 1, the Y would go at 10, 1, and the Z would go at 11, 1. So it just would move automatically from our print statement. So that's how we find the actual cell that we want to start printing at. We just set the cursor, and again, the first number is the column, the second number is the row. Okay. All right. So with this begin function, or this begin method, we spoke about we have 16 and 2, talked about that, and it positions it at 0, 0. But realistically, what this is actually doing is just telling the Liquid Crystal library something about your hardware. If you had a piece of hardware that had 32 columns and 4 rows, you would set up the begin with 32, 4, right? It would be a different number. But our piece of hardware has 16 and 2. If you get this wrong, it just might look a little bit different than you're necessarily thinking, but it's always going to come with the hardware specs to let you know what the best way to set this up is, set the LCD up is. And in our case, we have 16 and 2. But that's all we're doing, right? So these can be different numbers if you have a different piece of hardware. So jumping back into these 6 pins that we have set up on our Arduino board, what we have to do as the Arduino developers is set the wiring up in such a way that the liquid crystal library gets the appropriate signal to the LCD. So what I mean here is if we look at our first parameter, in this case 12, that 12 is going to have to be aligned to one of the inputs on the LCD. And if you look where the purple arrow is, kind of in the right-hand corner of the LCD display, you can see the numbers for the inputs to the LCD itself, to the actual hardware. And you'll notice here, there's still 16 inputs to the device, but they started at 1. So they don't go from 0 to 15, they actually go from 1 to 16. This is going to be something that you're going to have to deal with for the lifetime of you being a developer. You'll find some libraries, they start at 0 to 15, some of them start at 1 to 16. So just be careful with it from time to time, just pay attention. But here, the inputs to the LCD start at 1 and they go all the way to 16, right? And so we need to align our digits or our digital pins from our analog board to the proper input pin on the LCD. And so here you can kind of see this is how they count out, right? Just 1 to 16 like we spoke about. And what we are going to take a look at now is here 12, our pin 12 must go to pin 4 on the LCD. This is us actually putting a wire in there, right? We have to do that. The LCD library is expecting that whatever the signal on 12 is going to go to pin 4 on our LCD. And RS, we'll talk more about what the signals mean for this, but it's just called the RS pin. That's the 4 pin, right? 1, 2, 3, 4, not 0, 1, 2, 3, but actual 1, 2, 3, 4. 12 will go to the 4 pin on our LCD. And same exact thing, only now when we look at our 11 pin, right, it's our 11 pin from our Arduino board must go into pin 6 on the actual display. And that's just our E pin, enable pin. But these are the actual wires that we have to get right. Otherwise, the liquid crystal library is going to send wrong signals all over the place. So it's very important that when we wire it up, and we'll see this in the board in just a little bit, that we get these values correct. Next, when we look at the 5 pin, we're going to take our output, or our output from our 5 pin on our Arduino board to the D4, which is the data line, on the LCD. Same exact thing when we're looking at our 4 pin. That's going to go out to our D5, our data line. And again, you need to make certain that these are lined up properly. And again, you'll see this when we walk through the board, but keep this in mind, right? And so exact same thing. 3 is no different. This is another data line. This is just data line 6. And then 2 is going to be identical. And we go out to data line 7. Okay? Now let's talk about these for a minute. As we're looking at this, like we said, our first number here, number 12, has to go to our RS pin, which is just a register select. And what the liquid crystal library is going to do is it's going to send a message to the display to say whether or not you're about to send a command or either get ready for a command or get ready for data. And this is not something you have to worry about. This is something the Liquid Crystal Library is going to take care of for you, but this is useful information to have to understand what's going on behind the scenes. Again, you don't have to do anything, right? You didn't see anything about RS pin high, low, 12 pin high, low. We didn't do any of that. Liquid Crystal Library took care of that for us, but this is what it's doing for you underneath, right? It's just telling the display to get prepared. Next, when we look at our 11 pin, the Liquid Crystal library is going to set that up to the enable pin. And here you can kind of think of the enable pin as go ahead and accept the data and then kind of go to a lower voltage for a little while. And this is, you know, power consumption and heat, right? So you don't want to try and read in everything if there's no new commands there, right? So the enable pin is going to kind of say, hey, you're now enabled to go ahead and read either the data or the commands that are about to come in. And that's what comes in on pin 5, 4, 3, and 2, those data pins. So the enable pin, you don't want it on all the time. The 12 kind of says, hey, get ready for a command. And the enable says, okay, I'm going to go ahead and read that. Once I've read it, then I'm going to kind of power down. So again, I don't cause, you know, things to burn out very fast. You got a lifetime of the electronics, whole slew of things. But that's what the E pin is going to do. Next, we're going to look at the 5 pin, which goes into our digital input. And it's pin 11, incidentally, on the LCD. But this is going to take the 0th bit of a binary number. And if we look kind of down towards the bottom, you see that that one number in red. That's our 0th position bit. And that's what, whether it's 1 or 0, high or low, that's what the number 5, or 5 from our Arduino board, is going to go into pin 11 on the LCD. Right? That's a data bit. And so 4, 3, and 2 are going to be identical to this. They're just going to take in different digits of the binary value, and they're just going to go into different pins, right? And so in this case, our Arduino digital pin 4 is going to go into the pin 12 of our LCD, and it's going to read in this first position bit, right? Again, so we got the 0th, 1st, 2nd, 3rd. And that 3rd position, in this case, we also call the most significant bit. And again, 3 here, no different. Now we're just looking at the second digit of our half a byte of a 4-bit data set. And again, 2, it's going to read what we call the most significant bit, or you know, you could call it the third as well, right? 0, 1st, 2nd, 3rd, and that's it, right? So really, 5, 4, 3, and 2 they align to the digits within a binary number, and they go right from 14, 13, 12, and 11 pins on the LCD. Again, this isn't something that you need to necessarily control. It's good to know about it, to understand what where you have to align your wires, because you do have to set up the board. But this is what the liquid crystal library is going to take care of for us. And again, we'll see the wiring up when we walk through the board here in just a little bit, or really in the next video. So with all that being said, when we look at this setup, we should have a much better understanding of really what's happening, right? So we call to begin. We tell the LCD or the hardware that you are, capable of 16 columns and 2 rows, and we initialize the cursor to 0, 0. And so when we print out ask thee, right, we get this. Next, we're going to move the cursor down to 0, 1, right? Column 0, row 1. And here, we are now ready to print out our next message, which is crystal ball. And so that's how everything pretty much lines up. You'll get this as soon as you call setup. And what we're going to do now is take a look at the loop. And when we're looking at the loop, there's really just a few things here that are going to be maybe a little bit outside of what we've already talked about. But we have the digital input, right? The digital read. We've seen this plenty of times. This is what reads in when the button is pressed, or if you're using that tilt sensor whenever it tells you the board tilted. But I'm using, like I said, I'm changing the hardware to press a button. And the first thing that I'm going to do is take a look at my current state. And what this is going to allow me to do, I'm not going to print out new messages if they're not holding down the button. So if the switch state is low, meaning the button's not pressed, I'm not going to do anything. I'm just going to return. I'm going to make certain that my previous state and my current switch state are aligned. But outside of that, I'm not doing anything. That's what the return does, right? Hey, I'm exiting this function for now. Call me again in 1 millisecond or 10 milliseconds, whatever the cycle is that you have for your board. The next thing I'm looking at is I'm looking at the current switch state. If it's pressed, that means it's high. And I'm going to look at the last time I was in this loop. And if the previous switch statement was also high, that means they're holding the button down. And I don't want to cycle and burn out my my display by trying to give a new message and write to it just because they're holding the button down. So again, if they're holding the button down, it means my previous state and my current state are both high. I mean, last time I was in this loop, they were also holding the button down. I'm just gonna make certain that my two states are aligned, and then I'm gonna return. I'm not gonna do anything. And kind of aligning the states here is more out of an abundance of caution, but I set them and then I return. Don't do anything. Call the loop again in a few milliseconds. Now, once I have the switch state as high and my previous state was low, now I know that they just now pressed the button and they are expecting to see a new message. So I'm going to go ahead and set the previous state to the switch state. So if they do continue to hold it down, I don't get into this, the same problem I was having before. But this is if we're at this line now, that means they have just pressed the button. So the very first thing that I'm going to do, and this is where that reply variable comes into play, is I'm going to select a random number between 0 and 7, right? And so I have 8 options. I know that I'm going to get a number. I'm going to give it 8 potential, and those 8 potentials are 0 through 7, okay? And so I get this random integer back, and we'll look at how this integer is used to give us a random statement here in just a minute. But for now, we just get a random statement or a random number back between 0 and 7. And 0 and 7 inclusive, right? So 0, 1, 2, 3, 4, 5, 6, 7. Now, if you remember, we talked about the cursor moving automatically as we print out to our LCD. And so if we look over back at the display right now, the graphic, our cursor is over in 13.1, right? Because we printed everything out. Well, when we give the user a new statement, we don't want it to be there. Plus, the information ask the crystal ball, they already did, right? That's why they're pressing the button. So we need to clear out the text as well as reset the cursor so we can print out the next I guess, message for foresight. But the way we're going to do that is we're going to call our clear method on our LCD, right? And this is another method within the liquid crystal library. And what this is going to do, and this trips up a lot of people when they call it clear, all that the clear message is going to do is wipe out all the text that's on the display. But it's not going to move the cursor. It's just going to clear out the text. So if you don't move the cursor, the next thing you start printing out, you're going to get this kind of ugly kind of loop around. It could be if you got lucky, but it's probably not going to be exactly what you want. So you need to make certain that this cursor is actually reset as well. And we're going to set that cursor back to 0, 0. At this point, now we are ready to start giving our next message. And so the very first thing that we're going to do is we're going to say, hey, the crystal ball says, and then in a moment we'll get to the magical message, if you will. But for now, we just print out the ball says, right? We started at 0, 0. So now our cursor is moving on, and now it's back at 13, 0. So we need to make certain that the actual message is on the next line. So we need to go to 0, 1. And so we're going to set that cursor to 0, 1. And now we are absolutely ready to print out the magical message. Now, how are we going to do that? Well, we have this reply, and it's a random number. We don't know. It's going to be between 0 and 7, both inclusive again. But we're just going to call a switch statement. And we're going to use that reply variable. And in our switch statement, we're going to choose which which message to print out. So we're going to take a look here at the switch statement. So all the code that's in here, I'm just going to shrink that down and have just kind of put it as a 3-dot ellipse just to say this code hasn't gone anywhere. We just need to kind of focus on the switch statement here. So these 3 dots represent the code that we were just looking at a moment ago. But now we're going to take a look at the switch statement and what it really means. We're going to pass in that reply, which is a random variable, right, 0 to 7. And depending on what that integer was, is going to print out one of these random messages. So let's say hypothetically that reply came out to the number 3. We would hit this switch statement. We would go to the case that has the number 3, and we would print out that message. In this case, that's nothing more than Outlook good. And that's it. Then we go back through, we do the loop again, and next time we release the button and press it again, we'll get a new message. And so really, that's really all that there is to it. You can see that, there's a lot to hooking up the Arduino board to the actual display, but the code is pretty straightforward, and the reason it's straightforward is because we're leveraging that liquid crystal library. So with all that said, you should have a pretty good understanding about kind of the connection between the board and the liquid crystal display. So what we're going to do in the next video is go ahead and take a walk through that board and see how we get everything wired up. All right, we'll see you in the next video. Take care, everybody.